Welcome back, Geometry Crew. Today we're going to go over day 2 of our SAT chapter, which is going to deal with solving word problems using systems of equations. So the last video talked about just regular systems of equations and how to solve them. Today what we're going to focus on is the word problems using systems of equations. Now on the SAT, they love putting problems like this, like systems of equations, word problems, a lot of times really lengthy word problems, as their questions on the SAT in the math section. So we're going to just go over 5 examples, really simple examples of solving word problems using systems of equations. So in example 1, we have a theater earns $3,640 from a concert. A total of 148 orchestra tickets and 76 balcony tickets were sold. An orchestra ticket costs 3 times as much as a balcony ticket. What is the price of each type of ticket? Now, when we're talking about systems of equations here, usually in these problems, we're going to have 2 different equations. All right, we're going to have equation 1 and we're going to have equation 2. Now, a lot of times, these equations are going to be talking about the amount and then also the cost. So in a lot of examples like this, one equation is going to talk about an amount of some sort, and the other equation is going to talk about the cost of some sort. So in the very first sentence, we have something talking about the cost. So the theater earns $3,640. So if we add up all the tickets that were sold, right, we'd get $3,640. All right, and we're told how many tickets we have. We have 148 orchestra tickets and 76 balcony tickets. So just for simplicity's sake in this first one, because I don't want to use O as a variable, I'm going to use X and Y here. Okay, so orchestra tickets are going to be X, and then balcony tickets are going to represent are going to be Y. So we have 148 orchestra tickets plus 76 balcony tickets, and that would give us a sum of $3,640. So in this case, X refers to the price of an orchestra ticket, and Y refers to the price of a balcony ticket. So we can write down that first equation. So 148 X plus 76Y equals 3,640. All right, now the last little piece of information that we're told is in that third sentence. It says an orchestra ticket costs 3 times as much as a balcony ticket. Now, this one isn't directly telling us, you know, the amount of something, but it's giving us kind of a little ratio or proportion. All right, so it's saying an orchestra ticket, so the price of an orchestra ticket, which would be X, is 3 times as much as a balcony ticket. Is means equals, so X equals 3 times the price of a balcony ticket. So that's where we get our second equation. So we've got 2 equations here that creates a system. We can solve this system using substitution or elimination. Now in this case, we already have X equals 3Y. So it'd be simplest if we use substitution. So where we see X in that first equation, we're going to put 3Y instead. By doing so, now we've eliminated one of the unknowns. So now we just have one unknown. So that means we can solve this thing. So 148 times 3y is going to give us 444y. 444 plus 76 is going to give us 520. So we have 520y equals 3,640. Divide by 520 on both sides, and we get y equals 7. So the cost of a balcony ticket is $7. Now we can use that to figure out the cost of the orchestra ticket. And that second equation there is a really simple equation that compared the price of the orchestra ticket to the price of the balcony ticket. All right, so the orchestra ticket was 3 times the balcony ticket. Well, we know what the balcony ticket is. All right, we know the balcony ticket's 7, so 3 times 7 is 21. All right, so that means the price of the orchestra ticket is $21, and then the price of the balcony ticket is $7. That's it. All right, so the most challenging part of all of these types of examples, word problems in general, is just figuring out how to rewrite the equation. All right, if we can figure out how to rewrite the equation, usually the algebra is fairly simple. Okay, of course there's always exceptions. Let's take a look at example 2. All right, so in example 2, there are a total of 64 students in drama club and yearbook club. The drama club has 10 more students than the yearbook club. How many students are in each club? All right, first thing that we could do is just assign a variable. We know what this thing is talking about. It's talking about students in the drama club and students in the yearbook club. Okay, so we can use a variable to represent, the people in each club. So we could put D for the drama club, we could put Y for the yearbook club, and that'd make it pretty simple. It says the total of both of these clubs is 64. So if we add up all the people in the drama club with all the people in the yearbook club, we'd get 64. That's great so far, but we still don't have enough information to figure out how many students are in each club. We got to have that second sentence. The second sentence states the drama club has 10 more students than the yearbook club. All right, how I like to rephrase this is the drama club is the same as the yearbook club, okay, but it's got 10 more students. So the drama club is the same as the yearbook club, or D equals Y, except it's got 10 more. So the drama club is the same as the yearbook club plus 10. So D equals Y plus 10. Now we've got our two equations. Once again, you can use whatever method you want to solve. You could even use graphing if you wanted to. You can use substitution, elimination. If this is the calculator portion of the exam, you could totally you could type this into the y equals screen of your calculator, hit second, calculate intersection, and that'll give you, that would give you the solution. But in this case, I'm just going to do it by hand, either using substitution or elimination from day 1 of systems of equations. Okay, and in this case, we're just going to use substitution. I already know what D equals. D is just Y plus 10. So where we see D in that other equation, instead I'm going to put Y plus 10. So we have Y plus 10 plus Y equals 64. Combine our like terms. Okay, separate our constants and our variables, so subtract 10. And then isolate our variable, so divide by 2. So we get y equals 27. There's 27 people in yearbook club. Once we got that, figuring out how many people are in drama clubs, pretty easy. All right, one thing that we could do, it's not our only way of figuring out how many people are in drama club, but we could just substitute that 27 into this equation. So we have D equals 27 plus 10. So that means there's 37 people in drama club. Double check our answer. If we just add 37 plus 27, we get 64, which is supposed to be the total. And then also to double check, okay, the drama club in this instance has 10 more students than the yearbook club. So we know that this is the right answer. All right, next example. In example 3, says an adult ticket to a school play costs $5 and a student ticket costs $3. A total of $460 was collected from the sale of 120 tickets. How many student tickets were purchased? Okay, a lot of people get tripped up on this example because this second sentence. Right? A lot of times, one sentence will talk about one equation, another sentence will talk about another equation. Okay, and if we're thinking that way, we're thinking that this 460 and 120 is in the same equation. All right, if we're thinking that way, we're probably going to get a little deceived there. All right, so in this case, like I talked about in example 1, a lot of times these word problems, one equation is going to talk about the cost, the other equation is going to talk about the amount of whatever we're tracking. In this case, it's tickets. We have two equations that we could construct, one talking about the cost and one talking about the amount of tickets sold. So before we get to writing the equation, we want to define our variables. So we've got adult tickets and we've got student tickets. All right, so to just make these make sense, adult tickets are going to be A, student tickets are going to be S. If we're writing the equation for the cost, we know what the cost equals. It's $460. Okay, how we get that cost is the adult ticket costs $5. So for every adult ticket, we charge $5. For every student ticket, we charge $3. All right, so 5A plus 3S equals that 460. There we go. All right, it's $5 per adult ticket, $3 per student ticket. Now, the second equation is going to talk a bit about the amount. All right, that's 120 tickets. All right, now we don't need that 5 and the 3. Remember, the 5 and the 3 was talking about the cost of these tickets. If we just want to talk about the amount of tickets that are sold, that's just A and S. So this is just going to be the sum of A and S. A plus S equals 120. If we add up the amount of tickets sold, we get 120 tickets. Now from here, since we have our two equations, we can use whatever method we want to our disposal. All right, in this case, I'm going to go with elimination. All right, I like elimination. A lot of times that's my preference over substitution. So we've got to create a set of opposites. I'm just going to choose A to eliminate. So if I want to eliminate A, I've got to change this so that it's a negative 5A, opposite of 5A. All right, what I need to multiply by the second equation to get negative 5A is negative 5. And this is times negative 5. I could write it in front, which I normally would, but I don't want it to be cluttered here. All right, I'm just going to write that resulting equation down below. So if I multiply by negative 5, I would get negative 5A minus 5S equals negative 600. And now we're going to combine these two equations. I'm going to write this right underneath here. And I know that's very light. Hopefully you can see it. And we're going to combine these two equations. So this was the top equation. This was the new equation after we multiplied that second equation by negative 5. When we combine these equations using elimination, that's going to eliminate one of the variables. And remember, it eliminated A because I chose to figure out what would eliminate A. All right, now with our S's, negative 5S plus 3S would give us negative 2S. Negative 600 plus 460 would give us negative 140. If we divide by negative 2, we get 70. So 70 student tickets were sold. So we can easily figure out how many adult tickets were sold. On this one, we could just use common sense, but if this were a more difficult example, we would probably plug it in. So if we plug it in, we could plug it into the top or the bottom equation. Notice the only coefficient here is 1 in the bottom equation, so I'm going to plug it into the bottom equation, because if the coefficient's 1, that's going to be a lot easier. If we plug it into that bottom equation, we have A plus 70 equals 120. Subtract 70, and we get 50. All right, so 50 adult tickets were sold, 70 student tickets were sold. Awesome sauce. Let's go on to example 4. Okay. All right, in example 4, it says a business with 2 locations buys 7 large delivery trucks and 5 small delivery trucks. All right, right in that first sentence, it's telling us what the variables are. We got large delivery trucks and small delivery trucks. So I'm just going to use L for large delivery trucks, S for small delivery trucks. Okay, location A receives 3 large trucks and 2 small trucks for a total of $270,000. All right, so we can write an equation there. That equation is talking about the cost from location A. All right, so 3 large trucks would be 3L, 2 small trucks would be 2S, and that total is $270,000. So 3L plus 2S equals $270,000. For location B, they received 4 large trucks and 3 small trucks, and that gave them a total cost of $375,000. So for location B, which is going to be our second equation here, we have 4 large trucks, 3 small trucks. If we add those costs together, we would get $375,000. All right, so once again, we've got a system of equations here, and it's up to you to solve that system. Hopefully, solving the system is the easy part. Okay, the hard part really should be to decipher from the information given what are the equations in that example. All right, so we could use substitution or we could use elimination. Dealer's choice there. I'm going to choose elimination. So I'm going to figure out, okay, what do I need to multiply to create a set of opposites? And what do I want to get rid of? Okay, I always usually like to get rid of the variable that has the smaller coefficients, because then that means I need to multiply by a smaller number, which gives me smaller numbers as a result when I'm all said and done with these equations. All right, so I'm going to choose to get rid of S because the coefficients are 2 and 3, and that's smaller than 3 and 4. The common multiple between 2 and 3 is 6. Okay, that's the lowest common multiple there. So one of them has to be a positive 6, the other one has to be a negative 6. And it doesn't matter which one is which. So I'm going to create a negative 6 by multiplying that first equation by negative 3. When I multiply that whole equation by negative 3, that's going to give me negative 6s. Then I need a positive 6s. So I'm going to multiply the second equation by positive 2, because that's going to give me a positive 6s. All right, so I'm going to write down the 2 resulting equations here. When multiplying that first equation by negative 3, we get negative 9L minus 6s and equals negative 810,000. Now for the second equation, when we multiply that by 2, we're going to get 8L plus 6s equals 750,000. Now we're going to combine these. So the s's are going to be eliminated because we have a set of opposites here. Now, in terms of the l's, negative 9L plus 8L is negative L, or negative 1L. And then when we combine these, negative 810,000 plus 750,000, we get negative 60,000. All right, to get rid of that negative, we can just divide by negative 1 or multiply by negative 1. And that brings us to a cost of $6,000 for a large truck. Now to find the price of a small truck, we just got to plug that 60,000 into either one of these equations. All right, so I'm going to choose to plug it into that top equation. So instead of L, I'm writing 60,000. All right, now we're going to multiply here, get 180,000. Subtract 180, 180,000 on both sides. And we get 90,000 divided by 2, and we get 45,000. So a small truck is $45,000, large truck, $60,000. All right, final one, last one. I'm going to clear this. Now let's scroll down here. This one can be tricky. It says the perimeter of a rectangle is 480 meters and its length is 150% of its width. Talk about confusing there. Find the dimensions of the rectangle. First, we got to know what perimeter is and how to find it in terms of a rectangle. All right, so that's an equation that, maybe you already know. It says the perimeter is 140 meters. Okay, but if we don't really know how to find the perimeter, that's not really helpful. I'm just going to draw an image here. All right, there's our rectangle. The perimeter of any object is just adding those outside lengths. Okay, we want to find the distance around that object, and that's what the perimeter is talking about. So if I label this, all right, the width and the length of a rectangle is going to be the same. So that actually generates our equation for us. Okay, 2w plus 2l is the perimeter. If we know the perimeter is 480 meters, 2l plus 2w is 480. Now it says its length is 150% of its width. Once again, trying to be confusing here. Okay, that it's saying the length is, all right? So the length is just means L equals 150% of the width. 150% is just 1.5. So the length is 1.5 times W. So that means we can, instead of L, put 1.5 W. So we're using substitution here. 2 times 1.5 is 3. 3W plus 2W would be 5W. Divide by 5. We get W equals 96. So the width is 96. Well, the length is 150% of the width, or 1.5 times the width. So if we do 1.5 times 96, we get 144. All right, so the width is 96 meters, the length is 144 meters. All right, folks, that's it. If you have any questions, make sure to email me. And like always, have a nice day.